The moon doesn't have weather like we have on Earth, so we don't have erosion problems. So a lot of history, for example, of the sun's impact and the fingerprint it has left on the surface of the moon is still recorded for billions of years on the moon. So you can do work to understand by looking at the influence of the solar wind, if you will, on the moon and what's been left behind. You can learn a lot about the history of our sun and the formation of the solar system. You can dig into the geology of the moon and learn about its formation and the formation of the Earth and maybe how all the planets formed. The fact that we may find ice water in craters is a whole other field that has not just scientific interest, because that may be early cometary material that's been preserved for billions of years, but also practical applications from exploration. If I can find hydrogen and oxygen in the form of ice, that has tremendous implications if my technology guys can figure out how to turn that into a useful material for astronauts to drink or use as rocket fuel. So those are just a couple of the areas. There's a whole idea of how you would do astronomy. From the backside of the moon, you can do radio astronomy where it's quiet and you don't have to worry about all the interference from Earth sources. There's lots of different fields, and hundreds of objectives have been listed.
Next question, if any? If not, thank you very much to our panel members today. And for those who want more information about NASA's exploration program, you may visit the World Wide Web at www.exploration.nasa.gov. Thank you very much. Goodbye.
This remote outpost in space is one of civilization's most visionary undertakings. It is the International Space Station, and for at least 10 years it will orbit our planet every 90 minutes. Bigger than a football field, it will fly up to 450 kilometers above us, clearly visible in the night sky. Among the goals of this permanently inhabited laboratory are technological development, scientific research that would be impossible on Earth, and preparing humans to live in space. It is not science fiction, it is real, and it promises enormous benefits for people everywhere. Designing, launching, and soon operating the space station is creating a unique partnership among the United States, Russia, Japan, Canada, as well as the European Space Agency. Canada's contribution is the critical robotic system technology that will be used to assemble, service, and maintain the station.